In this assignment, we will talk about session and sorting. For the outline, we will talk introduction about session. In session, we will talk about binary search. In binary search, we got iterative, recursive, and then we'll talk about linear search. And then last, we will talk about sorting. In that sorting, we will talk about bubble sort, selection sort, insertion sort, merge sort, and quick sort. And then we will talk about summary. In session, session is a data structure refer to the process of finding. Uh, in another way to define session is that the data structure is desired element occurs simple specific characteristics in collection or idea. Session can be done in sequential or non-sequential. Like sequential search can be called linear search and binary search. These are the two common search methods used to find element in data structure. The general in binary search, binary search can be defined as session algorithm for finding an element position in sorted array. It can be implemented only on sorted list or idea. So we need to sort them first if the elements are not sorted already. In binary search algorithm can be implemented in two ways, iterative method and recursive method.
I will talk about the example. Here we declare an integer array name, sorted array. Let x equal to 4 be the element we want to search. We have to, next thing is we have to set low and high pointers. And low is the zero index of the array and high is the last index of the array. So we have to do sorted array dot length -1. Uh, the next thing is we have to find integer mid. So we have to do mid equal to low plus high by 2. Uh, the next thing is we have to compare middle element of the array with ace. If ace is greater than sorted array mid, we have to write low equal to mid plus 1. If ace is less than sorted array mid, we have to write high equal to mid -1. The last thing is repeat. So we have to repeat finding mid element and compare it with ace. This part will be presented by Mr. Will.
We use this sample to search binary search algorithm with using iterative method, and we're going to search index of 4, and in this method if array mid is equal we equal the value of the value that we search, we will then mid, and if mid is lower than the index, we will go to the left side, and the value of the low will be the mid +1, as the value of the high will be mid -1. Next. Okay. This is the same example to search by binary search algorithm, but we use with recursive method. It's all the same, but in here, if array mid array is greater than the index that we search, we use the mid -1 again in the return method. Yeah. Next. BO is a notation used in computer science to describe how the running time of an algorithm grows as the input size increases. It is a standard way to compare the efficiency of different algorithms and provides an upper bound on their performance. The worst case of the binary search occurs when the element is to search is in the first index or last index. In this case, the total number of comparisons required is log n comparisons. The average case of binary search is a measure of its expected performance on a random input, and in this case, it has a time complexity of big O log n, where n is the number of elements in the sorted array being searched. The average case assumes a uniformly distributed input, which may not always be the case in practice. Sorting is the common operation in computer programming that involves arranging elements in a particular order, such as ascending or descending order, based on their values. In Java, it provides several built-in methods and libraries for sorting arrays and collection. A good sorting algorithm also needs to ensure that elements having the same value don't change their locations in the sorted array. Sorting is necessary for getting a concrete understanding of data structures and algorithms. Most of these algorithms are extremely flexible themselves and can be implemented with both a recursive as well as an iterative approach. That's my part.
Yeah, okay. The result is the simple comparison based sorting algorithm. That's really compare adjacent element and sort them if they are in the wrong order. The result rely on multiple sort instead of a single line selection sort. Here's how it works. Firstly, you need to start your program and then run two loop, an inner loop and the outer loop. Repeat steps and the other until the outer loop are exhausted. That means it's finished. If the current loop is inner loop is smaller than its next element, so the value of the two element, and then you will got the sort the array. And this is the example. We want to sort this array 6, 2, 4, 9, 3, 7, and the first step is next line. You need to compare the first in the first iteration. You need to compare the first two elements 6 and 2. So they are in a wrong order. So you need to sort their position. So in the you can see in the right figure 2 and 6 like this. Next slide, please. Okay. Here you see the second element and third element 6 and 4. So they are also in the wrong order. So you need to sort their position. Now also in the next slide, 6 and 9 in the right order, so we don't need to sort their position. And then 9 and 3 is in the wrong order, so we sort them. And then 9 and 7, so they are in the wrong order, so we sort to 7 and 9. And okay, then 9 is already placed in their position, so we don't need to post 9 and next iteration. Okay, in the iteration 2, firstly we need to convert the first and second element 2 and 4, but they are in the right order, so we don't need to replace their position. And then 4 and 6 also they are in the right order, so we don't need to sort them. And then 6 and 3 is in the wrong order, so we need to sort them into 3 and 6. Okay, like this. 6 and 7 is also in the right order, so we don't need to compare them. Okay, like in the first iteration, like 9, 7 already in its final position, so we don't need to run it in the next iteration. Okay, next slide, please. Okay, in the iteration two, like we always do, we start compare first and second element 2 and 4. They are in the right order, so we don't need to sub their position. And then 4 and 3, but they are in the wrong order, so we need to sub their position. And then this is the result, right? Next slide, please. Okay, in the iteration two, is the position already in their position, so we don't need to do anything. So okay, this is the result. The left side I'm sort the result, and the right side I'm sort this away. Okay, this is the algorithm for in Java. Okay, you can see in the we want to find the array we want to sort the array 6249337. So we just put in the methods by sort. This is the algorithm for sorting. Right, first, this is the recursive, right? Because method in the methods. So like this, first run for loop, and then I will do like this. Okay, that's all. Yeah, that's all. This slide will be presented by slide on 7.
Okay, for the big or the runtime is approximately quarter when doubling the input quantity for unsorted and setting sort element. The routine for element sorted is setting order increase linearly and its order of magnitude smaller than for unsorted elements. The runtime in every case is slightly more than twice as high as the worst case. And next slide, please. Next. For the summary, binary searching and bubble sorting are essential algorithms for searching and sorting data. Binary searching is useful for quickly finding elements in the sorted list, while bubble sorting efficiently sorts small to medium-sized data sets. Both algorithms are valuable tools for any programmer to master. Thank you very much for watching. That's it. Yeah, we move lại.
That's all. Thanks for your listening.